seeing these curves across. One of the things you see a lot of papers talking about, I can hear myself. Hmm? Is it okay?
I was just checking audio video.
Okay, okay. So people talk about it's A, B, C, D, E. I guess I can't do this easily. Okay. So why is this happening all of a sudden? And I'll be mentioning more about that in a second. But the public and private keys are protected by the identity agent. The agent manages them on behalf of the owner. And consent tokens, so people exchange consent tokens to be given permission. So one person can give somebody else permission to access a resource. But we need so everybody has an identity agent. So that's kind of an impediment. But that's kind of like giving everybody Signal, everybody WhatsApp or some other tool like that. Challenge. You need some other things though, and you need to be able to exchange digital identities because of the way this thing's designed, right? Because the private keys are controlled by each person's identity agent, but the public keys are made available to anybody you might connect with. And I'll explain a few more things in a second. So in the cloud, I'm kind of showing that these are the sort of functions that are going on, including things like proof of possession, proof of custody. Interface point of view, this is depicting a person with their own identities in their wallet. It depicts their contact list, the identities of others. They have an event log, consent tokens, of private data are also stored in the identity agent. And I have this AD is really the authentication data and some kind of authenticator that's somehow implemented in the device. There's other things up here. I've called this image, the image of the, I've called that an image. It's sort of like your golden copy or identity, and you control it. You don't want anybody else to have it. You won't give it to Microsoft or some online service, your healthcare service. And there are more details, but you can define these, you could potentially define these ideas to be anonymous, pseudo-anonymous, anonymous, or identifying, right? Like a driver's license. So you could have an electronic driver's license or an electronic or digital business card. That's where I would start, with a digital business card. So a question on this?
Is the audio coming from your laptop?
No, it's coming from here, yeah.
Okay, let's just mute the.
I thought I'd muted it already, but I guess it needs remuting.
We'll unmute your microphone here. Just mute your, this microphone's not working. Right.
You have to use the mouse.
Oh. This. Will. Did we get you out of the presentation real quick? Oh. All right, can you test real quick?
Talk.
Is it still like
I'm
that?
here.
Testing?
Testing, audio testing.
It's stuck in,
Want to turn on the
yeah.
speaker, right?
Are we?
We have it. Yeah, that's what okay. I didn't know exactly what you're doing.
Yeah.
Okay, good time for a quick question or two. Just don't understand what's going on. And how much time we got? Do you know?
We have a good, 45 minutes.
35,
Sorry,
25 minutes.
So one question, how does this differ from like,
Which one?
the map teaching and teaching?
I'm not sure. I don't think Matt teaching. Oh, keychain. Oh, is that a blockchain solution? Or no? Oh, the keychain. Oh, yeah.
Well, I think. Sure, how to differ. It's different. I haven't done an examination from that point of view. Maybe when we do a few more slides, you can tell me.
Well, part of it, I can see it's probably like a teaching function, which stores private information. It doesn't have private information for other people, but generally, all the, the access stuff is sort of teaching. It's like the DPN certificates.
There might be some overlap. I'm not saying there wouldn't be, but so that's some homework for me to do.
I think one of the things probably missing is this exchange, identity exchange server.
Maybe. So have you used it?
No.
Oh, okay.
I haven't seen an identity exchange server anything. But my question is, okay, how do I address this?
Oh, yeah, no, that's the bottom line. You have to have a good software engineering strategy to implement these agents, and then have a strategy for testing them. And then when you issue new versions to control and distribute them in some way.
Yeah, well, it's like Ronaldo, sent me his credentials, his identity credentials. Okay, I don't know if it's really Ronaldo.
Yeah.
It's wants me to send all this stuff to Ronaldo or.
Well, that's the reason for having a trusted exchange service or having a proof of existence service. So it's kind of like a little bit like a DNS server that might be distributed across the web potentially. So that you know that, the public copy of your digital identity has gone to somebody else. And when you try to communicate with them or anybody else who has an identity agent and you've exchanged digital identities with, they have public copies out there, and you use the public-private relationship and the crypto keys to secure and digitally seal whatever you want, including your digital identity, like I'll do an example here of self-sealing, but there's other cases where you're sealing somebody else's because they've given a copy of your data and you've sealed them. Or I have an example of an online case. I have some of these cases.
We have. Some certificate authority has said, yeah, really, this is
They're right.
But yeah, in case someone purchased an identity for their website, for their URL. And you can verify it because the certificate authority, that certificate is on your system. So you can follow the chain of authentication back up to some.
Yeah, the idea here is not to have a centralized authority. Okay, the web servers all rely. We have really decent software security actually when it comes to client server, but the problem is that passwords are that's the headache. And that technology is amazingly robust. It's still working after all these years, albeit a value added with second factor. So now we need to have second factor or else we're kind of unsure, right?
I'm reminded of those who said.
I didn't hear that.
You're not in front of the camera, we're not including.
Oh, okay. Well, okay, so let's be patient a little bit with me here on this. Just on this slide, try to point out that these digital identities can be
Anonymous or
identity
or
and you can have an identity that's anonymous. That might seem counterintuitive, but you might want to be anonymous when you're browsing, posting stuff. But you want to be able to prove that you were at a certain place at a certain time, or somebody else might want to prove that somebody posted something at this time and they're anonymous. So that's might be valuable.
we have all these people
Thinking they're somebody,
on social media. But you knew
they're
they're
actually
anonymous and you say, well, maybe we shouldn't be, maybe that's fake news, right? No, I mean, if I
knew that somebody
was anonymous, that maybe I
say,
should
I'm going to
ignore that. And I
listen to it. I can't believe it. The other part here, the
crypto keys, like 6 keys. It seems like a lot of keys, but the idea is on the personal side,
providing stronger crypto assurances. And so you're signing, the keys you use to sign are different, sign and verify are different.
the keys are
To decrypt and encrypt message, for example, simple one. Or for digital seals, you emboss and inspect keys. So digital seal is different.
Is there a particular way to have in multiple keys? Because my understanding is that we use the same key for all of them.
Well, you could, but I think the cryptographic strength is weaker. So there's a guy that advised, I've forgotten this guy's name. It's in the paper, who recommended this kind of strategy to strengthen cryptographic strength. So separate your signing from your encrypting from other cryptographic functions you might have. And the embossing inspecting part of it has to do with emulating
notarization function, notarizing some digital component.
digital artifact. So that's that. So digital seals, I've sort of visualized them because part of all this is visualizing things. Somebody uses it, they can say, oh, okay, that looks like a driver's license
Business
card.
card.
Oh, it's been signed by somebody. It's been signed in this case by Sovereign Image. But it could, I mean, one of the examples I give, it was signed by the online service that that person used. And there's some other details here. And there's a
Digital
seal signature, I call it, which is relating it to
the fact that that's a digital seal and not something that's been used. That's that key, that particular crypto pair is not used for, say,
signing
signing
or
or encrypting.
and of course you want to have a
Place to put your,
good people.
these are public copies, so
Alan here is a copy of Alan's business card. So I have a copy of it. I have 3 public keys,
I can use the public keys to do things.
like verify that he signed something. Okay, or verify that digital seal, he's digitally sealed something, right? The other notion here is that there's an application programming interface, so other tools can use the agent. Okay, because the agent is controlling things, and controlling their identity, controlling the identities you have that are public, other people's identities. It's protecting this information. And the identity agents can talk to the other agents, identity registry and the exchange service. And these things are needed because you want to be able to
Alan wants to be able to get that.
to me somehow, right? And he can do that by using the identity registry, the proof of existence. And I can check that it actually came from somebody who said he was Alan. Okay, and then I can go and take other steps to elevate identity assurances. And
Or Alan and I use
exchange service to exchange.
public copies of our digital identities. Okay,
So what I see happening here is that what this would do is structure a virtual identity layer. Okay, by embedding identity agents into a physical device. So instead of having your wallet and contacts in some service that's tied to an online service, you're actually controlling your digital world. You're controlling your digital contacts. Your application is controlled by your identity agent. You use your identity agent, and it doesn't do anything that's going to get you into trouble. That's my philosophy, if you like. It's not going to reveal your private keys if it's locking them up. And it's implementing some protocols. You can imagine here's just an example of two devices, two users talking to each other. They have their wallet and contact and other things. And they can communicate through these collaborative applications like email. And email might transfer somebody's digital identity in the clear, or it might be used to exchange IP addresses so that they can exchange their digital identities using the exchange service.
The exchange service
An adapted Diffie-Hellman implementation. So
identity,
the protocol would have to talk to the registries, the exchange
service, the identity
registry, and
exchange
could
service.
be duplicated kind of in a distributed fashion, like DNS service on the internet. And the protocols for agents talking to each other, verifying things, would be direct IP to IP communications. This is since we only have about what, 15 minutes? Yeah. I could leave some of this. What I'd like to do is try to cover these next slides so that when you read the paper, it'll help you kind of, when you read or if you read, hopefully you'll read the paper, you get a sort of sense of where this is going.
Because all these figures are
In the paper,
well,
maybe not exactly the same, there may be a slight changes. So the owners exchange the digital identities. Okay, how do they do that? They can do it online or in person. They can use a proof of existence registry, which isn't clear, but you can verify things. Diffie-Hellman, well, there's a little bit more beef there. Or they can be to point, because they might be together. You might want to exchange your digital identity with somebody using NFC, tap.
So this is
So
the idea that Bob and Alice can exchange their digital identities.
public copies only. Once they're successfully exchanged, they can, and they're self-sealed. So the little, you see Alice's identity over here is self-sealed, okay? And you'll notice that this is illustrating the idea that Alice self-sealed it before she transmitted it, and Bob did the same thing. And then once they get those public copies, they can exchange things. They can sign and encrypt their transaction. So that's ideas talked about a little bit more in the paper. The identity registry, the idea here is that things are hashed. So your digital identities are hashed and deposited in the identity registry. So making your personal information much less vulnerable to a given registry or a copy of the registry being hacked. So this illustrates Alice sending her digital identity to Bob, Bob checking, well, Alice first registered it, then Bob checks the registry. He can do that because it's the way the cryptographic sequence works. I won't kind of describe that, it won't take too much time, but it's written up fairly carefully. And Bob does the same thing. Bob registers, Alice can check it, and they say, oh, well, we got each other digital identities now, we can safely communicate with each other. So that
Animation describes that.
you'll see a section covering the digital identity exchange service.
This is one
They would use one-time passwords or codes that are
generated by their
identity agents. They can then use those to encrypt and use the public key to encrypt and hash or they can hash the OTP to encrypt the public copies into the exchange service. So the exchange service only has public copies and they're hashed. And then they can combine them. Once they retrieve them back out, they retrieve each other's, they check each other's, they deposit and check each other's public keys. Then they say, okay, I now have a public key I can trust. And then they create a symmetric key to encrypt the transactions both ways. We have the same symmetric keys at the two ends of the transaction. That's roughly how Diffie-Hellman works. Okay. There's a little note below here is the OTPs could be computed from the public copies of their digital identities. They'd probably take a crypto key and do this. The identity proofing, there's a fairly decent description that's trying to animate the idea that you're going to have different sorts of people communicating and exchanging their digital identities and then attesting to those identities and using the endorsing key, the embossing key to seal the other person's identity. Here, the notary, they're talking NFC, so they're to tap communications. It's illustrating the idea that, well, Alice is getting her digital identity signed by the notary. So the notary is saying, well, this is Alice. And that information is embedded in the seal. And or Jim is another example of sealing that same one. It could be different digital identities of Alice that are sealed, but so I'm just put one in there, make it a little clearer. Or your Good Samaritan Health Group is able to digitally seal your digital identity, and then you can use that perhaps when you go into a pharmacy. This is my digital identity here, and here it's been digitally sealed by Good Samaritan. Please give me my drugs, hopefully good drugs. Okay, then there's an illustration in there of collaboration. How are we doing on time? You know?
Yeah, 8 minutes.
There's a scenario in there on time. So this is illustrating the idea that Cal, me, I worked with two other people, Alan and Connie, Jane. That's actually a picture of Connie, my wife. And they have done that. They've digitally sealed the digital identity. So I presented to somebody else. Well, look, these other two people who are well known in the industry, or they have their doctors, or they're people we can trust. They've sealed them, so why don't you use it? So you can see that my public copy, my sovereign image, that's my private copy, and there's my public copy. No private keys, and that can then use that to communicate with me. But what they can do, in addition, though, is they can go through a sequence where the agents do this on behalf of the user. You can proof of possession check. So I can use a cryptographic challenge, right? To challenge that, okay, is this really Cal's digital identity that I've got here? I think it might be. Seems to be visual things that tell me it is. But the agent will say, well, okay, let's do a proof of possession challenge response. That's what that means. Proof of custody verification. That would be, well, I want your identity agent to verify that you're present. So the identity agent will say, okay, Cal, you got to log back in, use your digital fingerprint to log back in, and then it returns to the relying party, and they say, oh, okay, he's present. His device is holding it. I can go ahead. I can verify, and the seals. So it can go off, and the agent can say, well, okay, is that really Jane Doe, or is that really Alan? And it can go off and check that. And this is all behind the scenes. So there's identity checking going on. From a user's point of view, it's very visual, but from the implementation view, you can see there's some complexity. So hopefully you'll be able to do that. I put in digital identity exchange service because that's another way they could exchange their digital identities. Or if they were in the same room, they could use an NFC tap to exchange their identities.
They can use the ceiling to go to exchange server.
I can't hear you, Joe. Say.
Oh, they can use the identity of people who sealed it to verify your identity. That also.
Yeah, well, that's what that step 6 would be, okay, well, okay, I'm glad you're there. Your agent says you're there. This looks good, I think, but I want to check with these 2 other people that have sealed your digital identity and communicate with them to confirm your identity, right? If you don't have, if there's no relationship, then it would have to set up a relationship and do some further checking. And it might require, okay, give me your identity, exchange it through an identity service or exchange it through an identity registry. So that I know that that's really you. So it's a kind of a recursive thing. So I didn't want to show all those loops, but it could drill down and come back up. Make sure you're really talking to who you think you're talking to. There's always risk, but this way you're not depending on some rogue web service that just fake their URL and captures your information, right? Transitioning, I do have a thing here on transitioning. So there's a sequence here that's illustrating here that Jim has an online service with a global professional network, NLink. I think I called it NLink. And nothing to do with LinkedIn, but could be. And so Jim says, okay, I got an online password. I get into NLink and NLink logs me in and I do what it can give me. It gives me the services. So now I want to be able to use this digital identity so I can upload it. So what do? I upload it. Well, uploading goes through a process, right? Well, as long as I'm logged in with a password, it's uploaded, then NLink, that service in NLink, okay, the identity agent in NLink can do a check. I said, okay, is that really the person they say they are? Okay, I know they're logged on. Okay, I'll do some further checking. I'll check the seal, I'll check the transfer. It could be self-sealed. Various things could be done to elevate the identity assurances associated with the identity that's transferred. So there's an assumption here, at least, that NLink web service and the password is working, right? And it's probably using HTTPS to do it. Okay, we're just about done. Come on in. And so
This
sort
sequence
of repeats and just, oh yeah, that's when they get online. I'm sorry, there are 2 parts to it. That's getting your, uploading your digital identity and then coming online later and using only your digital identity, not using your password anymore. So that part of the sequence is shown. So there's various comparisons and checks done in checking digital seals. Oh, delegating consent. Well, I'm going to do this one real fast. We're just about at the end. I got two more minutes, right? So this shows the sequence of a requester asking for access to the owner's private data that the custodian has. So there's a custodian. I put my private data out in the cloud, and Microsoft or somebody in the cloud is protecting it, right? Right. And custodian and the requester says, well, I want access to it. So instead of having sort of a handshake with custodian and, I've forgotten the name of the standard that's out there, commonly used for this kind of thing. Instead, you do it on a peer-to-peer basis. So you put a request in, and you'll see down here that the owner needs to digitally seal this. This is like like a notary seal. You notarize it. The relying party notarizes it, uses their identity agent to do that. Then sends that to the owner. The owner says, well, okay, I want to make sure this is clear. This is me. I digitally sealed it. Okay, owner's digitally sealed it now. And the owner said, okay, I'll give consent. There's nothing I have. I'm happy with it. I think it's you, etc. And then the grant is issued, which is another token. So the relying party, the custodian and the owner have both issued the grant in a chain, right? And the requester can now use that consent token every time they access this resource. So this allows, this facilitates the owner that's owning this information, this private information, to turn it off, right? I'm going to remove that consent. Don't have to go back to the requester. You can say, okay, these are the resources. My identity agent tells me I've given certain kinds of consent for, and I can now remove that consent. And user, I don't do this. I don't rely on some web service to do it for me. Okay, and I have done this. I do talk about this in the paper. NIST has a kind of a identity assurance and authentication assurance model, and I tried to map this on there. So no authentication, weak identity assurances, moderate identity assurance, superior identity assurances. You can see that there's various conditions that have to be met. So I won't say more about that right now. And then I do have a reference model that I put together. Okay, which show what an identity agent, what the design and implementation of the reference model would look like.
The PDF of this document has already been posted to
Yeah.
Cal's profile for this particular topic. Please refer to it. We will try to do a follow-up virtual video.
Oh, yes, I'm fine. We're done. We're at the end.
Because this is a important technical document, technical topic. We do need to talk about it. We're just running.
Oh, sure, of course.
Sure.
So if anybody wants to take my card as a reminder and send me an email, I'd be happy to send you whatever you might be interested in, like some of the references in the paper and so forth.
You can be the rest of the day.
Oh, yeah. I'll be sticking, I think I'll go to Cheerful Tortoise